Hello students, for class 10, today I am going to start polynomials. Polynomials, the second chapter. First, let us know what is a polynomial. First, we should know polynomial. An expression of the type a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 plus an x to the power n minus n is called a polynomial. Where a0 means a0, a1, a2 dot 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 an are real numbers and a0, that is a0, not equal to 0, and n is a non-negative integer. Okay, so this is the definition of a polynomial. A polynomial is often expressed as p of x is equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot dot dot. Similarly, last term will be an, because x to the power n minus n means x to the power 0 and x to the power 0 means 1, so we are not writing. The non-negative integer n is called degree of the polynomial. The non-negative integer n is called the degree of the polynomial. A polynomial of degree 1, that is p of x is equal to ax plus b, where a not equal to 0. A polynomial of degree 1 is also called linear polynomial, like 2x plus 3, like 7x minus 11, etc. These are called linear polynomial. Now you all are thinking why these are called linear polynomial, because the first degree, that is degree 1, with one variable always represents a straight line. That is why these are called linear polynomial. Similarly, a polynomial of degree 2, that is p of x is equal to ax to the power 2 plus bx plus c, where a not equal to 0 is called a quadratic polynomial. Clear? A polynomial of degree 2, that is p of x is equal to ax to the power 2 means ax square plus bx plus c, where a not equal to 0 is called a quadratic polynomial. A polynomial of degree 3, that is p of x is equal to ax cube plus bx square plus cx plus d, where a not equal to 0 is called a cubic polynomial. So a polynomial of degree 3 is called a cubic polynomial. Now, what is the degree of the polynomial? I think you all are thinking, sir, what is the degree of the polynomial? Now, degree of the polynomial means you see that for every polynomial x is the variable. The highest power of the variable is called the degree of the polynomial. Okay? The highest power of the variable, here the variable is x, so the highest power of x is called the degree of the polynomial. Okay, next, let p of x is equal to a naught x to the power n plus a1 x to the power n minus 1, we are writing in general, plus a2 x to the power n minus 2 plus dot 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 plus an. Be a polynomial, then the value of x for which then the value of x, that is then the value of the variable x for which p of x is equal to 0 is called the 0 of the polynomial. Is called the 0 of the polynomial. Suppose when x takes the value alpha, then p of alpha is equal to 0. Then alpha is called the 0 of the polynomial p of x. Alpha is called 0 of the polynomial p of x. A polynomial of degree can have up to n numbers of zeros. So, a polynomial of degree 1 has 1 0. A polynomial of degree 2 has 2 zeros. A polynomial of degree 3 has 3 zeros. A polynomial of degree n has n numbers of zeros. So we come to know number of zeros is related to number of zeros is related to the degree of the polynomial. Now graphical representation. A polynomial graphical representation What is graphical representation? A polynomial has as many zeros, as many the number of times the curve comes in contact. Comes in contact means either touches or cuts with axis of x, means x-axis. Okay, suppose I am representing, say, this represents, this is x-axis, this is y-axis, this is the graph of the polynomial p of x. Now what we have seen, how many times it cuts the x-axis? It does not cut the x-axis. Therefore number of zeros is 0. That is, it does not have any zero. Suppose I am drawing another. Say this is x-axis, this is y-axis. Now a curve is like this. Y is equal to p of x. How many times it cuts the x-axis? One time. One time it cuts the x-axis. Therefore it has 1 0. That is, for this one has no zero. Has 1 0. Like this. I am doing another graph. Say x-axis, this is y-axis, a graph is like this. So this is y is equal to p of x. How many times it cuts the x-axis? 1, 2, 3. So has 3 zeros. Similarly, I am drawing another graph. Say this is also a graph. This is x-axis, y-axis, and the graph is like this. It is y is equal to p of x. How many times it cuts? 2 times. There is has 2 zeros. Okay. So we get how many times it cuts the x-axis, that many numbers of zeros the polynomial has. Now we are going to discuss focusing mainly on quadratic polynomial. Quadratic polynomial. For polynomial relationship between zeros and zeros and coefficients of a polynomial if suppose the quadratic polynomial has two zeros and they are alpha and beta of the quadratic polynomial ax square plus bx plus c, then sum of zeros s is equal to alpha plus beta is equal to minus b by a. That is equal to minus b by a. Minus b, what is minus b? Minus b is coefficient of x square. So we will write minus coefficient of x, by. Now a is what? Coefficient of x square. Coefficient of x square and product of zeros p is equal to alpha beta, because the zeros are what? Alpha and beta. That is why the product of the zeros are alpha into beta, that is alpha beta. It is equal to c by a. Now c is equal to constant term by coefficient of x square, coefficient of x square. Now how to write the family of polynomial, family of polynomial p of x is equal to some constant k into x square minus s x. There is sum of the zeros into x plus product of the zeros p. It is the structure of a polynomial. That is, if alpha and beta are zeros, then the polynomial p of x is equal to x square minus s, means sum, that is alpha plus beta x, plus p means alpha beta. So this will be the polynomial. Now I am showing you how to find the zeros of the polynomial. There is the question is, find the zeros of the polynomial, of the quadratic polynomial, and verify the relationship between the zeros and the coefficients. Okay, let us write one equation. First I am doing 6x square minus 3 minus 7x. Here, first of all, we need to arrange the equation, the polynomial. Let p of x is equal to 6x square, so x power 2, then x power 1, so minus 7x, then constant term minus 3. Now obviously this is the middle term factor. 6, 3, 18, 9, 2, 18, 9 minus 2 is equal to 7. So let us factorize this one. This is equal to 6x square minus 9x plus 2x minus 3. This implies p of x is equal to, from the first two, 6x square and 9x, we will take common 3x. So 3x, 3 2 is 6, x minus 3 3 is 9, plus 1 common, 2x minus 3. So this is equal to 2x minus 3, 3x plus 1. Now you all know how to find the factors of algebraical expression. Now p of x is equal to 0. How to find the value of the polynomial? P of x is equal to 0 implies either 2x minus 3 is equal to 0 or x is equal to 3 by 2. or 3x plus 1 is equal to 0 implies x is equal to minus 1 by 3. So we have x is equal to 3 by 2 and minus 1 by 3 are zeros of the polynomial. Now sum of zeros. What is that? Sum of zeros means 3 by 2 plus minus 1 by 3. LCM will be 6. Okay, then 2 3 ja 6, 3 3 ja 9 minus 3 2 ja 6, 2 1 ja 2, 2. That is equal to 7 by 6. Now we can write 7 by 6 as minus of minus 7 by 6. Now minus. What is minus 7? Let us see the equation. Minus 7 is coefficient of x. So minus 7 means coefficient of x by 6. Now let us see 6. 6 is what? 6 is coefficient of x square. So coefficient of x square, and product of zeros p is equal to 3 by 2 into minus 1 by 3. 3 3 is cancelled. There is minus 1 by 2. Now minus 1 by 2 we can write it as minus 3 by 6, equivalent fraction. That is equal to, now what is minus 3? Minus 3 is constant term. By what is 6? Coefficient of x square. So coefficient of x square. So the relationship between the zeros and coefficients of the polynomial, different terms of the polynomial, how are they related? We have written the relationship and we have given a proof of the relationship. Pause.